Hi guys, it's Rob here with the Game Logic 1 tutorial for our mouse maze tutorial series. And basically what we're going to be doing in this tutorial is we're going to be going over how to actually set up the mouse maze. Now I went on, I believe it was mazegenerator.com. If you just Google search maze generator, it should be like the first one that pops up. And I created this maze, and it created this maze for me down here, and then I downloaded the PNG version of it. Then I dragged in some of our art assets here from our sprites folder onto here. You'll also notice that I made some of these objects prefabs. Now a prefab is useful because it's stored in the library and can be instantiated through code. But sprites can do that too. So what makes prefabs different? Well, any change made to the prefab in the library affects all the other prefabs in every scene. Additionally, and to zoom in here, it would just be, I'm just using the mouse wheel right now to zoom in and out. Additionally, if we made a change to this piece of cheese, let's say, and we wanted that change to be reflected in all the cheese prefabs, we would go Game Object, Apply Changes to Prefab. That's something important to note. So once we have our maze and we've dragged out these objects, we've dragged our cheese here. Well, right now I would suggest you don't drag out the cheese, you don't drag out the mouse traps, and you put a mouse here. So first order of business is what code is driving this functionality. So we'll take a look at our scripts folder here. Camera follow. So this camera follow script I actually took from Stack Overflow. So to give proper credit where credit is due. If you want to see the full script, you can go to this address here. And we're not really going to go over this script. This is more or less, you know, just the movement of the camera. And we not really, in this tutorial, you could pretty much just go to Stack Overflow and take that script. What I want to cover more is actually the functionality of the game itself. So just to give credit where credit is due, the camera is what makes our mouse, the camera is what follows our mouse basically, allowing us to continually see its position no matter where we move him. Now, I'm going to just play this game a little bit to show you guys, you know, for example, there's no colliders on the walls, but if we try to follow inside of the lines, we get the cheese, we see our energy goes up. Now I want to go into another mousetrap intentionally to show you guys, to point out something. We're going to be actually writing code, okay, for a mousetrap that disables our mouse's movement, or our mouse character's movement. In order to delineate between the computer mouse and the mouse character, I'm going to start referencing him as mouse character or computer mouse, depending on which one I'm referring to. So you'll notice that the position of our mouse cursor or our computer mouse, you notice I just clicked there, that disabled the cursor's visibility, right? Because I actually have a line in there that says cursor got disabled, but sometimes Unity only responds to that if you click once. Now I'm just trying to desperately find a mousetrap here. It's amazing that when you're actually looking for a mousetrap, you can't find it. But when you're actually just playing the game through, you can find them. What I'll actually do, I'm going to jump out, jump back in. The only thing I want to show you guys is notice here, we have a trap timer up here that is set to 5 seconds. You'll see it decreasing. Boom, and now we regain control of our mouse. Okay, now the end goal of this project is to have a full maze where our mouse gets from start to finish. And I'm going to show you guys how to do that in these tutorials. So first we're going to look at the move mouse script. Okay. Here's our move mouse script. So we have vector 3 position. These I don't even believe you need, because I was just, you know, messing around to try to work on this yesterday. With rigid body rig, that's going to be important. Public game object mouse. Okay, and I'm just going to kind of slowly scroll through this so that those of you following along could see everything here and can pause the video. More importantly, can pause the video if you need to copy some of this down. And also, some of this code was borrowed from Stack Overflow as well. I don't have the exact link right now, but that can be provided at a future date. But basically, what you want to do here, and when I say that, I literally just mean this movement system. So now what we're going to end up doing here is we're going to be looking through what this code actually does. In start, we will initialize cursor.visible to false, and rig to, we're going to get the component rigid body off of our mouse. This move mouse script is going to be on our mouse. Now, in update, we're going to have a game object M. We're going to have our position equal to input.mouse position, position equal to camera.main.screen to world point pause, and then pause.z equals 0, and transform.position equals pause. Again, this little neat tidbit I got off of like a website just like Stack Overflow, just to make my life a little bit easier. But once you have your mouse moving with that, now we can use some of these Unity tricks, some of these programming tricks to make our mouse turn. And this is where things get really fun. So we're saying if input.getAxis mouse X. So this is our computer mouse moving in the X direction, or down here in the Y direction. Less than 0 means left, more than 0 means right, greater than 0 means up, less than 0 means down, depending on if we're doing X or Y. And then we have some math here. The only thing you really need to know right now is make sure you have this negative in front of move. And if you notice all these different numbers right here, this is forward, this is left, this is down, and this is right. So you can basically just copy that. But now our void on collision enter with collision col as a parameter, and this is important. So if col.gameObject.tag equals cheese, we're going to destroy col.gameObject, and energymanager.energy plus equals 10f. Well, what in the world are we referring to? Well, if we go back to Unity and we click on one of these pieces of cheese, we'll notice that our tag here is set to cheese. How you would do that, you'd click tag, add tag, you'd hit this little plus, and you type in that name, but you're not finished yet. Now you're going to jump back to that piece of cheese. It's still going to say untagged. You're going to go down and click cheese. Excuse me. Now, the next step is that we're basically going to, now you have that, and now we also put a box collider on it. And you'll notice if I jump out of 2D mode, this box collider is a little bit bigger. That's to make sure the mouse and his box collider can interact with it. So we're basically using 3D objects, okay, with a 2D game. And you'll notice that with our sprite renderer here, our sprite is set to cheese. So now on that collision enter, the mouse obtains that piece of cheese, and you'll notice the energy is increasing. And if you remember, we said energymanager.energy. Well, why do we do that? Well, if we jump to our energy manager script, which I encourage you to create now, energy manager, then what you'll be able to see is that we have a public static float energy. Now, public static is used to reference, that's used when you have one variable that you want other scripts to be able to reference through referencing this script. So this is our major game states. So if anything that you want, you know, your score, for example, in a shooting game, that's going to be a public static because there's a lot of different factors that could go into that score. So here we want our energy to be controlled by one script, but be able to obtain, when we obtain the cheese, we want to increase that same energy. We do that through the use of a public static variable. In start here, we just initialize our timer to 0f and our energy to 20f. F delineates a floating point number in Unity. And in update, we're saying timer equals time.delta time. And if the timer is greater than 3 seconds, we're subtracting 2 from that energy. And then we're resetting the timer. So every 3 seconds, we're subtracting 2 from the energy. Now, if the energy is equal to 0, we're going to load the level, game over. Okay, now there's a few more things I want to go through with you. We went through 2 maze, we went through move mouse, and we went through energy manager and camera follow. Remember, camera follow is just something that you're taking off of this Stack Overflow link, and instead of times 5f, you're changing that to times 4f. Next, in the next tutorial, we're going to go over display UI, trap, and trap control. And that's going to finish up our game logic. Thanks for watching, guys, and I'll see you in the next tutorial.